As we start to look at some of our different isomers or different structural isomers, how we can start to arrange our molecules in three-dimensional space. Now that we've talked about kind of our unsaturated nomenclature, we do need to stop and take a look at our alkenes for just a second. Alkenes, again, being our double bond in which we've got two carbons bound together with one sigma, one pi bond, and then we've got two more coming off of our carbons. As a result, because we have this would be sp2 hybridization around each of these carbons. We end up with a kind of planar molecule, and then we have something, I don't know, it looks like this, where we've got this double bond in between, and then we've got our groups around them. And so the reason we got to talk about this is there's actually a couple different ways that we can start to build these molecules, and we need to be able to tell them apart. So there's a slightly new naming convention here as we start to look at our different molecules. We didn't have to worry about this so much with our alkanes, and that's because of the bonding type. And so for alkanes, because it's a sigma bond here, there's actually a rotation. These molecules can start to rotate around the end, and so we're ideally or theoretically these could end up at any spot around that sigma bond at any given point in time. Obviously, there's kind of hindrance or steric stability pieces here, but we're not worried about that. But we don't have to worry about it so much here. When we get to our alkenes, because we have this pi bond, we get locked. And so now where we start to put these functional groups or substituents matters, because we could theoretically have both of our chlorines on one side or the same side, or we could have them across or transverse from one another. So now, because again we're locked here, these two chlorines will always be opposite each other relative to this double bond. And so we actually have a way to do that. Cis and trans. I believe this goes all the way back to, is it Swiss Alps? I had an Orgo teacher one year teach me the relationship. Obviously it wasn't super important as long as I remembered what they meant. Cis being the same side or the same location, orientation. Trans being across. I was saying transatlantic or trans-Pacific or transnational. We go all the way across for trans conformers. And so if we're looking at our example here, we've got a carbon-carbon double bond. We can have one of two arrangements. We could have it where both chlorines are on the same side relative to each other of that double bond, or we can have it where the chlorines are opposite each other relative to that double bond. And so this would be our cis conformer. This would be our trans conformer. Because this is a two-carbon chain, our base name would be eth, but we've got a double bond in there, so it'd be ethene. We've got two chlorines, and so this would be cis dichloroethene. This would be trans. Ooh, didn't leave enough space. Dichloroethene. And so we'd actually include this cis and trans as part of the naming. So this is cis dichloroethene. This is trans dichloroethene. I know what you're thinking. You're like, why didn't I have to use numbers? Right? Why didn't I have to show that both of those chlorines were on different carbons? And the reason for that is if you had both of the chlorines on the same carbon, if you had a structure like this, this no longer has cis or trans conformation. This, theoretically, you could argue that, okay, I've got them both on here, I'm going to put them both on the other one. Whoop! So now they're both over here. Well, okay, you'll notice I didn't unpop any of the little poppy pops. It's the same molecule, right? It's just rotated. And so this would just be dichloroethene. We don't have cis or trans conformation. Because of that, we know that both of the chlorines must be on the same carbon relative to each other. When we start to look at this kind of cis versus trans, it only is a factor when we're looking at alkenes. Alkanes got the sigma bond, and so they could rotate, and we don't have a set conformation on these. When we look at our alkynes, our triple bond, we don't have this type of conformation because it's going to end up being linear across that triple bond. Here we end up with our sp hybridization, and as a result, we got a flat molecule. There's no worry, there's no other options as to how we start to arrange those constituent groups. Cool, a couple more examples for us to kind of look at and wrestle with. Let's say you have a structure that looked like this. Intentionally doing skeletal form here just to give you more examples of how we'd start to do this. If I'm thinking about my numbering system, I'm going to start to kind of give us some of those tips or hints, kind of lead us into this. I only got one functional group here, and it's closer to my left-hand side, so I'm going to start on the left hand with my number. I got 1, 2, 3, 4, 5, 6, 7 as I'm going across, so this is going to be a hept something. It might be, well, we know it's a heptene because we've got this double bond here, and it's between the 3 and the 4, so we indicate the first carbon that it is attached to. This is 3-heptene. Now the question is, do we have cis or trans conformation here? And it turns out we do, because not shown here are some hydrogens. This pi bond locks us into a fixed position. As I've drawn this here, my two kind of important groups, my carbon chain going off of my important piece or my double bond here, are on the same relative side of that double bond. This would be cis 3-heptene. If we wanted to make it trans, we would actually have to have that coming off the other direction. So we got 1, 2, 3, 4, 5, 6, 7 that we now have it coming off. And so if I were to take that hydrogen back off so we can kind of see it, it looks a little funny. It does, because now they're on opposite sides of that double bond. So this now has become trans 3-heptene. 1, 2, 3, 4, 5, 6, 7 carbon chain going across that double bond. Cool, and then we can add whatever functional groups we want. All the same rules apply. Number from the lowest total number and put it alphabetical. When we put our naming conventions together, we're just adding a cis and trans to show us which side are we ending up on that double bond. Cool, if you got questions, give a holler.